Once more, the James Webb Telescope, the most powerful instrument known to humankind for deciphering the mysteries of the universe, has made a groundbreaking discovery. Constructed with infrared capabilities far superior to any previous technology, the Webb telescope has identified a superhabitable Earth located just 40 light-years away in the TRAPPIST-1 system. This super-Earth, smaller than gas giants but larger than our own planet, resides in the star's habitable zone, where conditions appear suitable for liquid water and perhaps even life. It is an enormous discovery that raises fundamental questions. Could life exist on this extraterrestrial world? If so, what might it look like? What makes this super-Earth so unique? These planets, which tend to be rocky and up to 10 times Earth's mass, occupy a special place in planetary classification due to their greater gravity and denser environments. These conditions may create environments favorable to life as we know it, or even forms of life we have never encountered. Using the James Webb Telescope's advanced spectroscopic instruments, scientists detected methane, traces of water vapor, and oxygen in the super-Earth's atmosphere. These components, essential for life, make this planet one of the most promising candidates ever found. Not only does this breakthrough hint at a living ecosystem, but it also reshapes our understanding of planetary formation. The TRAPPIST-1 system, with its 7 rocky planets orbiting a cool dwarf star, has long enthralled scientists. 3 of these planets, including this super-Earth, lie within the habitable zone. The system's star, with its lower temperature, reduces environmental instability and the threat of extremely high radiation. However, the super-Earth's proximity to TRAPPIST-1 results in tidal locking, where one side always faces the star while the other remains in perpetual darkness. Despite these challenges, the planet's dense atmosphere may maintain a stable temperature range, potentially supporting life in ways we have yet to fully comprehend. The most exciting aspect of this discovery is the detection of potential biomarkers, chemical indicators in the atmosphere that suggest the presence of living organisms. Molecules like carbon dioxide, oxygen, and methane have been found in unusual proportions, implying that biological processes could be at work. These findings align with conditions observed on Earth where living organisms produce similar molecules during geological or biological processes. However, non-biological processes could also explain these signatures, sparking a flurry of enthusiasm among scientists and the general public alike. This discovery brings us closer to answering the age-old question: are we alone in the universe? Water, often called the essence of life, is a critical indicator of habitability. The James Webb Telescope's analysis of the super-Earth's atmosphere provided compelling evidence of water vapor, raising the enticing possibility of liquid water on its surface. The presence of water suggests the planet might have a stable hydrosphere, potentially with vast oceans. Combined with appropriate atmospheric pressure and temperature, these oceans could offer an ideal habitat for microorganisms or even more complex life forms. If the surface is inhospitable due to extreme temperatures, underground aquifers, similar to those supporting Earth's extremophiles, could harbor life. Despite its exciting possibilities, this super-Earth presents unique challenges due to its tidal locking. With one hemisphere constantly facing the star and the other in eternal darkness, extreme temperature zones may exist. However, researchers hypothesize that the planet's dense atmosphere could act as a heat distributor, transferring warmth from the day side to the night side. This could create a temperate region along the terminator, the boundary where day and night meet, potentially serving as a sanctuary for life. The interplay between light and darkness could lead to novel evolutionary adaptations, resulting in life forms unlike anything on Earth. This super-Earth's discovery would not have been possible without the James Webb Telescope's technological marvels. Its ability to investigate the faintest signals from distant planets has revolutionized exoplanet studies. Using infrared spectroscopy, the telescope identified chemical signatures in the super-Earth's atmosphere, detecting key molecules that suggest habitability. This innovation is just the beginning, as future telescope missions will build on these findings to explore this realm in greater detail. The rapid progress of technology is bringing us closer to resolving one of humanity's greatest inquiries. Are we alone in the universe? The discovery of this habitable super-Earth has sparked a renewed desire to explore other stars. Although the planet's 40 light-year distance is too vast for current spacecraft, concepts like nuclear propulsion and light sails are being explored to bridge the gap. Simultaneously, Earth-based scientists are intensifying their efforts, using machine learning to refine data from the James Webb Telescope. These efforts are yielding new insights into the planet's surface conditions and potential biomarkers. This finding has also rekindled public interest in space exploration, fueling calls for increased funding for missions to other planets and a renewed sense of purpose in the pursuit of cosmic discovery. Scientists are now focusing on identifying key chemical biomarkers, indicators that could point to the presence of life. Chemicals like oxygen, methane, and nitrogen oxide are under close scrutiny, as their presence in specific combinations may suggest biological activity. The James Webb Telescope has already detected carbon dioxide and methane, but researchers are looking for seasonal or unexpected shifts in these gases, which could indicate an active biosphere similar to Earth's. Although these findings are not conclusive proof of life, they add a layer of intrigue to this already fascinating discovery, encouraging further data collection. The most exciting aspect of this super-Earth is imagining what life might look like in its unique environment. With high gravity, a dense atmosphere, and the potential for oceanic ecosystems, life forms may evolve in ways we've never seen. Some scientists speculate that microorganisms could inhabit surface oceans, shielded from radiation, while others propose entirely novel life forms adapted to this alien world. Speculate regarding more intricate ecosystems, where the environment has been adapted by life under unusual circumstances over billions of years. These models are more than just tools for imagination. They have their foundation in Webb-collected data and provide valuable perspectives on how life might exist in other parts of the universe. As the amount of evidence for habitability rises, the question of what humanity should do comes up. If we come across evidence of intelligent life, the super-Earth's discovery has rekindled discussions about whether or not we should endeavor to communicate with extraterrestrial civilizations. According to some, reaching a sophisticated civilization could accelerate technological advancement and respond to fundamental questions. Questions from others, such as the well-known physicist Mioaku, advised against demonstrating our presence, as species may perceive us as a threat or a resource. The James Webb Observatory's findings raise this discussion, confronting humanity front and center with the implications for ethics and the existence of where it fits in the universe. The discovery of this super-Earth, which is very habitable, is not only a milestone but also a point of entry for the future of humanity in space. Gathering additional data, which is needed for advanced missions to investigate this faraway world, becomes more important. Projects like the revolutionary Starshot initiative, with the goal of sending microprobes to star systems nearby, are gaining traction. These little spacecraft could reach the super-Earth, providing humanity within decades its first in-depth look at an alien world. Efforts based on Earth, such as the building blocks of the next-generation telescopes, will keep redefining our comprehension of the super-Earth's environment and how it might affect life. The story does not end with the discovery. This journey is just the start of an exciting new era in the history of investigation of the universe. The discovery of a highly habitable super-Earth, as seen through the James Webb Telescope, is a significant step forward for humanity exploring the universe. This planet, because of its potential to hold liquid water, biomarkers in the atmosphere, and stable conditions, brings back the traditional query: are we the only ones in the universe? Despite the fact that the data gathered thus far raises more questions than it answers, it opens possibilities that redefine how we perceive life and our position in the universe. This finding is more than just a scientific accomplishment. It is an appeal to everyone in humankind's capacity for expansion and collaboration toward a common objective. We are on the verge of an interstellar future. The challenges that lie ahead are enormous, but so are the benefits. The search for extraterrestrial life is no longer a distant dream, but a real reality taking shape before our very eyes. If your interest has been piqued by this tale and made you want to look beyond our world, we welcome your participation in this journey. Join our mailing list and enjoy this video channel, and set the notification bell to be informed of the most recent James Webb Telescope's findings and more. Many thanks for keeping an eye out, and I'll see you in the next.